Without any further ado, I would like to ask Hubert Ruczyński, a student from Warsaw University of Technology, to deliver his talk on FairPAN, Achieving Fairness Through Neural Networks. Hubert, even though the presentation is pre-recorded, the floor is yours.
Good morning, I'm Hubert Ruczyński, and this talk is an effect of an amazing opportunity which I've grabbed during the previous summer. For 2 months, I've gained my first scientific experience during a Mi2 DataLab internship, where I could work along much more experienced researchers, and I'm really grateful for that possibility. Thanks to the people like my mentor Jacob Wisniewski, I've managed to generate enough will to go out of my comfort zone and participate in this project. As I've mentioned before, during the summer, I've become the part of Mi2 DataLab, and that was my first work and scientific experience. I've also become an R package developer, after that the implementation of FairPAN. Right now, I'm participating in the MIRE project, which is also a Mi2 DataLab's initiative, and our goal is to track and analyze European regulations about artificial intelligence. I also study engineering and data analysis at the Warsaw University of Technology, where I'm on 6th semester of engineer's degree, and of course, I don't plan to stop after obtaining that engineer title. Now, I'd like to present you to the outline of this talk. At the very beginning, I'll make a short, abstract-like introduction to this project. Later, I'm gonna talk about 2 important subjects which you have to be familiar with before introducing the FairPAN. The first one is the concept of fairness, followed by the simple examples of it. The second one is about GANs and the introduction to them. After that, I'll talk about how FairPAN works and why is it so good. I'm also going to prove that point by performance visualizations. In the end, I'll talk a bit about FairPAN package and its workflow. So, now without any further ado, let's get to the main subject. The main topic of our study was the implementation and further research in the area of obtaining fair tabular data classifiers with the usage of neural networks. To achieve such results, we modified the idea of GANs by swapping the generator with the classifier and adapting the adversarial to recognize the label of a sensitive value. This way, FairPAN, which stands for Fair Predictive Adversarial Network, should bring us much fairer predictions. As a result, we present a mitigation technique suitable for neural networks and explore this field even more. At the beginning, I'd like to introduce you to the concept of fairness. Consider the idea of the algorithm that has to predict whether giving credit to a person is risky or not. It is learning on real data of given credits, for example, German credit data, which were historically biased against females. In that case, the model learns this bias, which is not only included in the simple sex variable, but also is hidden inside other variables, so removing this feature doesn't make the model fair. As a result, the classifier is more reluctant to give credits to women, even if every other condition is similar to the ones of men. Other examples where this kind of bias is visible can be connected to the race or skin color of the person. One of the most known examples refers to the COMPASS algorithm, which was used by American judges to define the likelihood of recidivism of the prisoner. As the intuition might guide you, it was heavily biased against black inmates who were twice as likely to be misclassified as being high risk in comparison to white inmates. The violent recidivism analysis also showed that even when controlling for prior crimes, future recidivism, age, and gender, black defendants were 77% more likely to be assigned higher risk scores than white defendants. To read more about this particular case, I can encourage you to search for ProPublica's article about this. But now let's move to more day-to-day example where actually we could use fairness. Let's imagine that we are the director of the bank which uses such model. Personally, we are fully behind the equal treatment of men and women. But on the other hand, we have a biased model and we don't even know about it. In such situations, fairness proves that it is a really important part of explainable AI. The concept of fairness is sometimes really foggy because we can't always say if some variable leads to the bias of the model or is it just a good predictor. So I'd like to introduce you to my intuition behind it. I personally perceive fairness more like a tool to make your models suit to your personal beliefs, or we can even say that we want to make them politically correct. In other words, fairness is a concept which focuses on bias detection and mitigation in order to achieve outcomes fair in the understanding of the user. Before we can move on to the idea of FairPAN, I have to introduce you the concept of GANs, which stands for Generative Adversarial Networks. It is important to understand that because our solution is strongly inspired by the behavior of GANs. Generative Adversarial Networks are two neural networks that learn together. The generator has to generate new samples that are indistinguishable from original data, and the adversarial has to distinguish if the observation is original or generated. The generator is punished whenever the adversarial makes the correct prediction. After this zero-sum game, the generator eventually learns how to make indistinguishable predictions, and adversary's accuracy drops down to 50% when a model cannot distinguish the two classes, which indicates that generated fake data is almost the same as the real one. This concept is connected to two facts that are worth noticing. Firstly, GANs are most commonly used to generate indistinguishable pictures, but we can also use them to tabular data, what happens in FairPAN. Secondly, the accuracy drop of the discriminator happens despite it is learning and improving in its classification task, so we don't make it worse deliberately. Well, now as we finally know what fairness and GANs are, I can tell you more about FairPAN. FairPANs are our solution to bring fairness into neural networks. We mimic the GANs by subsetting generator with classifier, and the adversarial has to predict the sensitive value z only from the output of the predictor y hat, which is a vector of probabilities. Similarly to GANs, this zero-sum game is continued to the point when the adversarial cannot distinguish between two sensitive classes. In other words, it leads to the moment where information about sensitive value is greatly diminished or even lost, and it means that our model makes fair predictions. The crucial part of this model is the metric that we use to engage the two networks into a zero-sum game, which is captured in the following function. So, the model learns to minimize its prediction losses while maximizing that of the adversarial due to lambda being positive, and minimizing a negated loss is the same as maximizing it. The objective during the game is simpler for the adversarial because it only has to predict sensitive value based on the classifier's output, and this one is captured here. The adversarial doesn't care about the prediction accuracy of the classifier. It is only concerned with minimizing its own prediction losses. So during the whole process, it tries to get better at classifying the sensitive variable. Now, I'd like to describe the training process shortly. Firstly, we pre-train classifier and adversarial on a balanced dataset. Unfortunately, we need to have similar amount of privileged and discriminated observations for the adversarial to work. After all, it makes class prediction based on vector of probabilities only. Later, we begin the proper PAN training with both networks. We train the adversarial, provides its loss to the classifier, and after that, we train the classifier on a single random mini-batch. We repeat this process desirable amount of times, and after that, we should get predictions which are indeed fair. At this point, you might have asked yourselves a really important question. Why do we want to use such complex mitigation technique rather than use some other well-known methods? And why do we even want to use FairPAN package for that task? Well, regular mitigation techniques tend to worsen performance of the classifier by decreasing accuracy, for example, whereas FairPAN has no such drawback, and worsening of the performance is much smaller. Moreover, the package itself is very flexible because it enables not only to provide your own neural networks, but also to create one with our functions. The outcomes are also created with the usage of DALEC and FAIR models, so one can use their methods and visualizations. Additionally, the workflow of the package is really simple and clean because of multiple features available for users, such as preprocess function. At this point, I'd like to introduce you to some graphical examples of how FairPAN works, which includes knowledge about some metrics used to measure fairness. The example I'm going to use comes from adult dataset, where the classification task is to guess whether a person earns more or less than 50,000 per year. Presented visualization comes from the package Fair Models, written by Jacob Wiśniewski, and it represents 5 metrics which are most interesting for the creator. I can agree with this set of metrics because they are able to give us enough intuition about what is really happening in our data. On this plot, we actually see the ratios between discriminated group of females to privileged group of men in aforementioned metrics. We assume that the model is fair according to the particular metric when it satisfies the 4/5 rule. The 4/5 rule is satisfied when both labels in a sensitive class get similar results, which is between 4/5 and 5/4. On the plot, it is visualized as a green background color between the red ones. Now, as we know how to read such plots, I want to underline that the most important metric for us is the statistical parity ratio, called STP shortly. It is so valuable because it describes the similarity between distributions of our sensitive variables. As you can see, after the pre-trained stage, our model is performing quite poorly in terms of fairness because its STP ratio equals only 0.3, and the other metrics behave poorly either. To check if our model works properly, we've decided to track the 4 most important learning metrics, which are loss and accuracy of the adversarial model, accuracy of the classifier, and of course, STP ratio itself. These statistics indicate if the model is learning well and makes desirable progress. As you can see, adversary's loss function grows and its accuracy diminishes, which means that the adversarial is worse with every iteration. We can also say that the classifier makes fairer predictions because the adversary can't say which label is which. Last but not least, STP ratio also grows toward the 0.8–1.25 range, which directly means that predictions are fairer. As we can see from the last plot, accuracy of the classifier diminishes with every epoch. However, this loss is really small, and after all, we gain much fairer predictions while sacrificing only 2% of accuracy. Last visualization presents us the comparison between pre-trained classifier and final FairPAN model. As you can see, we've got almost perfect score for STP ratio. However, it didn't come to us at no cost. Two metrics, equal opportunity ratio and predictive equality ratio, have drastically worsened their own scores, but it can be easily explained. The adult dataset is heavily biased, and what we actually done during fair training process was generating more true and false positive for female class in order to make the distribution similar. These changes, however, makes other metrics change too, and it is clearly visible on the displayed plot. It shouldn't be feared, however, because the similarity of distributions is more important for us. In the end, I'd like to present you the structure of the package and say a few words about using it. First thing that I will repeat a couple of times is that the FairPAN is really flexible. Inside the workflow, we have many opportunities to provide our own methods instead of relying on the ones implemented inside the package. First example of this we encounter at the very beginning of our workflow. Although FairPAN data preprocessing is strongly recommended to use because it generates all needed datasets, this step is skippable and one can provide data preprocessed by themselves. After that, we have to use a dataset loader function which creates batches which are needed in the further creation of neural networks. The next step is the model creation, which is also highly flexible. The user can decide to create both models from the package methods and pre-train them right after the creation. However, it is also possible to create them manually and provide them at this step. One can also decide whether the models given are pre-trained or not, and provide the combination of models being pre-trained or not, which are visible on the right side of the graph. As a next step, one has to pre-train the networks if they are not pre-trained yet, And then we can move to the actual pretrained function. At this point, the user has to tune training parameters, such as number of epochs. It is also possible to choose whether model should acquire learning process statistics and if it should print them out. If we choose to save those stats in the next step, we can plot them and see if our model works well and achieve desirable results. These plots and statistics were presented previously on the presentation and are not changed in the package at all. They are basically the same. After the pretrain, we can also decide to use explain_pan function, which creates DALEC explainer, on which we are able to use all DALEC functions, which is a really powerful tool to data analysis. We can achieve the same with FairModel's fairness check, where we create fairness object, and it can be used in various FairModels functions. And most importantly, we can plot the fairness check plot, which is the essence of measuring the fairness. To briefly sum up, FairPAN is a competitive bias mitigation technique thanks to its low performance losses, applicability to neural networks, and achieving great results. It is based on the concept of GANs and efficiently uses it by swapping the generator with the classifier. Moreover, it is followed by an implementation of our open source package that is really flexible and easy to use. I can also recommend few articles and blogs for further research according to this topic. The first article is written by my mentor Jacob and head of Mi2 DataLab Przemysław Biecek. It describes FairModels package and contains lots of information about fairness. Second one describes the idea of GANs briefly, and it is probably the most known article in this area. Next two blogs by Stijn Tonks and Henk Griffin. These two actually implemented the concept of FairPAN before me in their Python scripts, and I were deeply inspired by their work, and I'm sad that it's not recognized as much as it should. And the last article describes FairPAN concepts from others' perspective than this presented in other articles and this presentation. So, thank you for your attention, and I'd like to encourage you to ask some questions about my work.
All right, we are at the session Q&A. Hello, Hubert.
Oh, sorry, I was muted. Hello.
Right now. Good. Nice to see you. Nice to hear you. All right, Hubert. There is a question on the chat. I also have 3 questions to you, so we can proceed with the Q&A itself. Mateusz is asking a question, and the question goes like that. If I understood correctly, you use the output of the classifier as an input to the discriminator. Have you considered using classifier's hidden layer as a discriminator input?
Well, actually, I haven't considered that. Actually, that might be a really interesting idea, because I haven't thought of that, because that was my first attempt to do anything with neural networks at all. So I weren't so much experienced then, but it sounds like a quite a good idea to at least try it. So yeah, that's a nice note.
So let's continue with my questions, and that's a question on the loss itself. Is the loss something that you came up with yourself? Is that something that comes out of literature, or basically, how did you come up with the loss itself?
As I said before, literally on this few last minutes of the talk. This work was inspired by these two articles, and it was their idea to use the loss. I had to slightly tune it because it wasn't. It didn't give good results when I use it one by one like they did it. But the whole idea was taken from their implementation.
Cool. Also, question from my side on the regular methods versus FairPAN. You mentioned at the kind of beginning of your talk that there are regular methods, and what is the difference between them and FairPAN? So I would like you to elaborate on these regular methods, if you can.
Okay.
How they work.
Okay. The regular methods are basically, the idea of them is not so smart, let's say. Not like GANs, because now some way it makes some ideal sense that okay, we are learning what is wrong with this data. And the regulars ones are okay, we've got some border, for example, we have some border samples which are in the middle of being considered as one side or the other, and then we swap this middle on the other side to balance the set. And for me, at least, it's not so intuitional, and they are more like based on some. I need some word and I don't remember it right now. Arbitral. So yeah, this way.
Cool. We've got also a question from Hubert Ruczyński, our keynote moderator. Dariusz asks, there are many different fairness metrics which contradict each other. Have you thought of creating a plausible fairness measure loss to meet different needs?
Okay, I need to read this question myself once. Okay, I mean, of course, as I'm reading this question, I haven't thought of creating such tool, and I'm not entirely sure what do you mean by this pluggable fairness, by this word pluggable here. But I guess it's not exactly the part of the I don't see it as the part of the FairPAN. Maybe it would be a better place for my mentors and my friends package for models.
Yeah, I think you can. Yes, I think
it's kind of hard question for me.
Right. I think if Dariusz is available on the chat, you can kind of clarify that on the chat itself, and maybe Hubert, you're able to answer Dariusz's question on the chat itself. Well, having that said, Hubert, thank you very much for your presentation and your contribution.
You asked 2 questions and you had the third one.
Yeah, but I think we are on exactly on the time.
Sorry.
We should continue with another presentation. So I think that's fine. And it also kind of answered my question. It was on the architecture of GAN, and you answered that at the end of your presentation. So having that said, I would like to thank you for your presentation, your contribution to Ghost, and the work was incredibly inspiring. And I also love the concept of you having the Mi sweatshirt and the Mi mug on your desk as well. So having that said, thank you very much. And
thank you too for this opportunity.
Thanks.